Can anyone hear me? Is that working? Cool, should be good. All right, so hey everyone, I'm William. I'll be leading the talent development team for this year Imperial College Data Science Society here. I'm very happy to be welcoming you on behalf of ICDSS for the very first lecture of this academic year. This will act as a taster lecture meant for freshers who want to get to know more about the Data Science Society and data science, and why you should join our society. This is actually the second run we've been doing. We had the first one last week, and we'll have a third one on the 9th of October for people who are in different time zones or have different availabilities. At any moment, please feel free to drop any questions in the Q&A section on the right, and we'll answer them as we go. Also, we'll have a quiz at the end with 10 £10 Amazon vouchers to win, so make sure to stick around. All right, let's go. First off, I'll tell you a bit about us. So ICDSS is a departmental society with the main objective of promoting data science awareness amongst the student body. We do that by providing opportunities for students to engage and learn about data science. In that regard, we cater events for people of all levels of experience and disciplines, and so we try to engage a huge variety of students from lots of different backgrounds and lots of different departments into one field, which is data science. As such, we have two main goals, which are building a community of data enthusiasts and bridging the gaps between students. So whether you are a fresher, new to Imperial, first off, welcome to Imperial, or you are a PhD doing your project, or you just have a side project, or you just want to know more, we try to really create content for everyone on that scale. To accomplish this, we have a dedicated committee, which you can see here. So we'll be serving you throughout the year, and really please hit us up, any of us, with the message if you have any questions or whatever related to ICDSS, and it'll be a pleasure to answer and help you. So more precisely, what will we be running this year? First off, on one side of the scale, for members who do not have much experience in programming, you'll want to start with our workshop series. We cover various topics, including data analysis, data visualization, machine learning, and programming. This will mostly be done in Python, as it is kind of the go-to language today for that kind of stuff. Over the course of the last years, we've achieved a cumulative attendance of over 2,000 students each year. So they've been pretty successful, and every year we iterate on our program and try to deliver a best effort, and this is even more true so this year, as everything is remote. We've had to change quite a few things from how we used to do it, but we hope we'll be able to teach you guys as much as possible and get you thrusted into the world of data science. Also, a big one that we host every year is AI Hack. It's actually the largest student-led AI hackathon in the UK. It's quite young. It started back in 2018. We had 80 participants that were selected out of 300 applications, solving 7 challenges provided by companies such as Transport for London and Deliveroo. And last year, we scaled the event up to 300 participants, including students from other top universities all around the UK. And this year, for the first time, we'll also try to step up again and try to deliver internships as prizes for the winning team. An aspect we also want to focus on is having experts from the industry deliver their knowledge to you and us. So in that regard, we have regular talks by data scientists from industry to provide insight into actual real-world applications of data science. Over the past few years, we've had speakers from, for instance, JP Morgan, Expedia, LinkedIn, or Uber. And also in that aspect, we'll be running conferences with external speakers that are not necessarily representing companies, but that just have some really cool stuff to show us. And we really want to broaden the opportunities for everyone here. Now, on the other side of the spectrum, for members who have knowledge on data science and who have already done projects or masters or PhD students, we have an advanced analytics consulting projects team, which provides hands-on data science experience for students to tackle real-world problems in an industrial setting. So concretely, what that means is that we might collaborate with companies or organizations that need a certain data science project to be done. So we put you in a relation with them. We create a team, and that team might not only comprise data science people, but it might also need some people from, say, mech eng or soft eng or bio, whatever. It's really depending on the mission, and we think this is really great to accelerate the development of your career and increase your employability. And so we hope that this program can also lead to internship interviews or offers. Now, by being a member, you are automatically in our mailing list, so you'll receive all the information about job vacancies, recruiting events, workshops, and all the stuff that's going on. To be on the mailing list, we'll have links later on, but also if you join the society, which is free, by the way, so you can just hop on the Imperial College Union website and join the society, and you should receive everything. Let's continue. So now let's dive more into what data science is all about. So at a high level, data science is about using computer science and math to discover hidden patterns and gather conclusions and insights from data that was collected. The skills that are required are therefore multiple. You'll need some computer science to gather and manipulate the data on a large scale. You need math and statistics to process and operate on the data. And finally, but not least, you also need domain expertise to understand and make sense of the results and to be able to draw meaningful conclusions. This is because a big aspect of the work is also to report to non-technical people or people from management who just want the conclusions, and so who might know a lot about their field but know much less about math and data science and computer science. So you really also need that domain expertise to kind of cross between the two worlds. The goal of a data scientist is therefore to use data in such a way to provide meaningful company for like a client or company. We usually distinguish between two types of data, which are structured and unstructured data. Structured data is highly organized and formatted, so just think of like an Excel spreadsheet or an SQL table. It's easy to analyze and go through it. And so, for instance, you can just have like credit card numbers, stock information, geolocation, all that sort of stuff. Other type of data, unstructured, is it has no predefined format, and it's much more difficult to process, but it's usually what's collected. So for instance, that would be like text, video, audio. There's no like inherent structure to it. And so we'll cover all that in our workshop series as we go. A fun metaphor, if you want, is so the world is a really messy place with lots of really unordered data, and our job as data scientists our end goal is to somehow process that data to make it easy to visualize for the people we're working for, and to get as much insight as we can from it. To address the hype around data science, because there's been a lot lately, it is mainly due to the fact that we live in the age of information, and as a consequence, everything generates information around us, absolutely everything. And this is an exponential trend. So it results in huge quantities of information, which needs to be ingested and processed to gather insights. And this is what makes data science so attractive and very universal, because any domain that generates data needs data science. So that ranges from agriculture to finance. So essentially, any hobby you have on the side, you can probably apply data science to it, which is super cool. And this is a big part of why it was coined the sexiest job of the 21st century. So if we can get you guys thrusted into that sexy job, that would be an amazing accomplishment. So also to while we're into it, there are a lot of terms that get thrown around these days, mainly around everything related to artificial intelligence, AI, or machine learning, ML. So to clear things up, AI is a very general term that kind of morphs and changes as time goes. It's usually used to designate the ability of a machine or a computer program to think, act, and learn like a human in an automated fashion. On the other side, ML, which is a subset of AI, is more precise and is defined as the field of study that gives computers the ability to learn without being explicitly programmed. Deep learning is yet another subset of machine learning, which is about using algorithms called neural networks, which are loosely inspired by the biological neural networks in our brains, and which we'll touch on quite extensively in our workshop series. Aside from that, data science is kind of the cross section, in that it's really about making discoveries and creating insights from the data and communicating these insights to non-technical people. Now, what is the typical workflow of such a project? Because these projects tend to be quite massive. So first off, everything is data. So this is the capture stage. You might have heard of the Internet of Things. So it's really about gathering as much data as possible from any source. Then once you have all that data, maintaining it at a large scale. So having, say, lots of distributed servers with redundancy and backups to store all that data efficiently and in a manner that's fast, because when you have like terabytes or petabytes of data, you really don't want to spend time and money on just waiting for data to be loaded and processed. So you really want to optimize that, which leads us to processing, which is all about it includes, say, data mining, which is extracting more data from the data you already have. So you already have some data, you can see some relation between it, and that will give you even more data. So that's part of the processing stage. Next, analyzing, which is also encompasses all the more so that's more typical data science. So creating models, modeling the data, using it to make predictions. And then once we have that, so now we have our insight, and then one of the most important stage, even though it might not look like it, is really communicating that information and extracting useful conclusions to see where to go. This is usually why now we hear a lot the term like data-driven company and stuff like that. It's really kind of that cycle of getting data, maintaining it, processing it, analyzing it, and then seeing, okay, now that we have those insights, where do we go from there? In that regard, A quick word about careers in the field. There are multiple career paths that can be taken. Firstly, data scientists are tasked with a high-level overview of big data science projects from end to end, so that they kind of know, they're kind of like more senior people and know a bit of every stage and coordinate everything. Data engineers are more involved in the maintaining and processing task, and they usually manage storing the data on a big scale. So that requires a lot of skills in, say, databases, cloud computing, and all that stuff. And finally, data analysts are tasked with answering queries from other teams and communicating these results back. So they're kind of like they bridge the gap between the data science team and all the other teams that are not necessarily experts in data science to answer their questions. Now, let's look at actual applications of data science. So first off, here we have an overview of the tools or technologies typically used by data scientists. We won't be using all of them, but we'll be going through quite a bunch, and we really encourage you to explore as much as possible on your side, or if you have any questions about anything. For instance, you've heard of like some framework, how does it compare to the one we use in the series, etc. Just feel free to ask, and we'll answer as you wish. Okay, so a big field is computer vision. So if you remember what I said about unstructured data, video and pictures are part of unstructured data. It's really hard for computers to extract meaning out of those like format of information, and that's the entire field of computer vision, extracting information from photos and videos. On the left, we have what's called a classifier. This happens to be a hot dog classifier. It was made by a team last year, AI Hack, and it seems like it works pretty well. And on the right, we have what's called the pose estimation, which is extracting a 3D mesh of a person's position out of a video. We also have other kinds of applications of computer vision. So for instance, we have a segmentation in the top image, which are applied a lot to medical imaging. So for everything related to sort of tumor detection and all that stuff, because it can be really difficult for doctors to spot tiny tumors in a photo. And it can also be used here. We have an example of image in painting. When say you have an image with corrupt data and you want an algorithm to kind of blend that back into how it was before. This is very similar to the technology that's used. You might have seen colorized photos of like pre-World War soldiers or whatever that used to be black and white, and that's kind of the same algorithms that are used to colorize those images. So it can also be used in a more sort of artistic manner as well. It's not just health. There are loads and loads of applications. Next on, we have natural language processing with a quick demo here. So this demo is using the GPT-3 model, which was developed by OpenAI. And essentially, you just write in plain English the description of a neural network model. So with the number of layers, what kind of layers you want, and it will generate the actual Python code to create that model, which is pretty nifty. So this is using GPT-3, which is a natural language processing model. I think it was bought recently by Microsoft, which has created quite a lot of contention in the AI field. It's the beef of the moment. And it can This was also used to generate some news articles, and so there are a lot of sort of philosophical and political implications to that, which is really cool as well. That's when you know you're working on something that has a lot of impact. Next one, we have reinforcement learning, which is we won't be touching so much on that, except if maybe there's a lot of demand, but we'll be doing all the rest already. So reinforcement learning is about teaching agents or AIs or algorithms to do something in a simulation using a reward system. So for instance, on the left, we have the game of Go. So most of you will probably have heard of AlphaGo, which defeated the best human player of Go in the world. And this was thought to be impossible because Go, unlike chess, which can be brute forced through mathematics, Go relies a lot on intuition. And so that was deemed to be impossible for a machine to win. But it actually worked. So it shows really the power of that technology, and the way it was built, kind of loosely speaking, is the agent or the AI just played against itself for many games, like millions or billions of games, until it actually excelled and beat the world leader. And on the upper right, we have an example of, again, OpenAI with StarCraft. And same, they achieved amazing results just by throwing the agent in the game and having it play against itself over and over again until it achieved like a super high level. Next, we have a very passionate member here in our team that will speak about causal inference, which is the study of whether X causes Y or Y causes X, and complex interactions between different endogenous and exogenous variables. And two, what is the effect of X implies Y? So this is really useful in everything that's related to pharmaceutical treatments, policymaking, A/B testing, and is a really important recipe for decision making, and has been the subject of a lot of research lately. So this is kind of like more apart from all the fancy like machine learning and everything, but it's still super useful, and definitely want that under your data science toolkit belt. So we'll have a workshop on that as well. Now I'll leave on to Lionel, who will do a quick demo of typically what we'll be doing in our workshops, and what projects we want to do.
Hi everyone, I'm Lionel. I'm the head of operations for ICDSS, and I will now be showing an example of one of the practical applications of machine learning. As we all know, coronavirus has been a huge impact to us all. For us students, many of our in-person activities have been cancelled, and most activities, including the ones that ICDSS will be organizing, will now be online. So many governments and health experts have also been advocating different kinds of guidelines, as well as social distancing. So how can machine learning play a role in this? As William mentioned just now about computer vision, we can make use of some of the computer vision techniques to help detect humans who are walking too close together. I'll now be doing a quick run through on how you can build a social distancing detector using machine learning. So to make a social distancing detector, we basically need to make an application that first detects humans, followed by calculating the distances between them. It needs to check if they are beyond a certain threshold and flag the cases that are violating the social distancing guidelines. We'll be using the pedestrian footage as shown in the GIF to test our application. So detecting humans lie in the field of object detection. An object detection task is basically a combination of image classification and object localization. In short, object detection algorithms produce a list of object categories present in the image along an axis-aligned bounding box, indicating the position and scale of every instance of each object category. So as you can see on the image on the slide, an object detection model is able to draw bounding boxes around a certain item, as well as identify its classification, such as whether is it a car, a person, a bicycle, even a traffic light. And here I've also listed some of the popular models used in this field. So first up, we got the RCNN family, which basically stands for region-based convolutional neural network. The main idea behind this network is basically to have three modules. The first being a region proposal module, which generates and extracts category-independent region proposals, followed by the second module, which is a feature extractor, which extracts features from each candidate region using a deep convolutional neural network. And lastly, a classifier module, which classifies the features as one of the known classes. And so under this family, we first had the RCNN, the original model, but it was afterwards, we also had a fast RCNN model as well as a faster RCNN module. Both of them are improved iterations of each other for both speed of training and detection. So next up, another popular family of object recognition models is referred to collectively as YOLO, which is basically you only look once. The approach basically involves a single neural network trained end-to-end that takes a photograph or frame as an input and predicts the bounding boxes and class labels for each bounding box directly, instead of having to go through separate modules to do region proposal and the classification. So RCNN models are generally more accurate, but YOLO models are much faster than RCNN models, achieving object detection in almost real time. It has gone through iterations of improvement over the years, and the latest official version being YOLO v4, which is the detection model that we'll be using today. Lastly, there's also efficient DET models, which were released by the Google Brain team. Efficient DET models basically uses Google's very own ConvNet model called EfficientNet as its backbone. I'm not going too much into the technicalities here, but we'll cover more in depth on what convolutional neural networks are later in our lecture series. So do not worry too much for now. The main takeaway here is basically to know what object detection is and the state-of-the-art models used in this field. So here you can see the output of a pre-trained YOLO v4 model that I used after inputting the camera feed into the model. For machine learning projects, it's extremely common to use pre-existing models that have already been trained on large data sets, and then further train those pre-trained models using a data set specific to your problem. This saves a lot of unnecessary training time instead of training right from scratch, and the process is basically called transfer learning. This model has been trained on the COCO dataset, which stands for Common Objects in Context. This dataset basically contains roughly 170 image classes and annotations across 100,000 of images. So human is one of the classes in the COCO dataset, and since we are only looking for human detections, we do not need to do any additional training, and all we need to do is just filter out the bounding boxes classified as humans. So this is the pipeline of our social distancing detector. It takes in camera feed. Let me just get my pointer out. It takes in camera feed, and for each frame, it sends through the YOLO v4 model over here and outputs the bounding boxes with the human class. Lastly, we calculate the distances between the human detections, and we can do so by taking a simple Euclidean distance between the centers of the two bounding boxes. This sounds simple enough. However, this is not going to be very accurate. So for example, in here, we have two humans walking almost in opposite parallel directions to each other. However, due to the camera angle and the way the bounding boxes overlap, our application would basically register a social distancing violation. But if you imagine yourself being on the field, this is not going to be true. So how can we solve this issue? Basically, we shall further process the frames first to obtain a bird's eye view. So at the very first frame, we get the region of interest that we are interested in within the camera frame and warp them such that we can get as close as possible to a view from the top, so that the detections won't face the false positives when humans are lined up at an angle to the camera, as shown just now. So to get a bird's eye view, we basically use OpenCV. OpenCV stands for Open Source Computer Vision Library, and it's a library that is commonly used to do image processing. We'll be using one of the geometric transformation functions in OpenCV called perspective transform, which takes in 4 points, as you can see here, 4 points, and is able to compute a perspective transform matrix, which then can be used to warp the image accordingly. So this is common in the phone apps that you use to scan your documents, such as Microsoft Lens or Scanner. So I've coded the application to first pause at the first frame, as you can see here, and allow the user to detect a region of interest of 4 points. Using that, we can proceed to get the perspective transform matrix and warp the frame to the one seen on the right. So on the right, you can see that's the warped version. It's practically kind of almost like a bird's eye view. We can also take 2 additional points to allow users to detect what the true distance threshold is. So for example, if the social distancing guidelines is set as 2 meters, we can add 2 points here and estimate it to be around the height of a human. And then warp those 2 points using the perspective transform matrix created before. And the distance between those 2 warp points will be used as the distance threshold. So finally, here's the final outputs of the application I made. On the right, it basically shows the camera angle. Green means that there's no violation occurring, but red means the social distancing violation has occurred. And you can see the bird's eye view on the left. It has additional lines showing the connections between the violated users. So over here, you can see 4 users walking too close to each other. So yeah, I think this was a pretty cool project, and just kind of shows the impact that machine learning can have on the various problems that we face in our everyday lives. So to sum up, here are the tools and concepts that we've covered in this mini project. For the tools, I used Python to code my project. So Python will be one of the commonly used language you will see in data science projects. TensorFlow is next. If you have some experience using YOLO before, the object detection model, you would have known that YOLO is implemented in .NET, which is basically written in C and CUDA. But for this project, I've used a TensorFlow implementation of it. And of course, you also have OpenCV, which was the library that I used to warp the image to get a bird's eye view version of it. And the concept required would be convolutional neural network, which is the underlying concept for all the object detection algorithms out there. So all these tools and concepts will be covered in our lecture series one way or another. And your Python skills will definitely improve throughout the lecture series. If you would like to check out the code for this project, you can go to the GitHub repository on our ICDSS GitHub page. GitHub is basically a platform where people can store their code and work together with others on it with version control. So this is for those who have not used GitHub before, can kind of like imagine it as like a Google Drive, but more complicated. But yeah, so other than this, you can also check out our other data science workshops through the repository at the bottom. This will be further updated in due time as more lecture materials are created. Yeah, so now I'll pass my time back to William, who will be covering more on the upcoming workshop series.
Cool, great stuff right there. So yeah, a quick word about the workshop series we'll be running. So let's go a bit more in depth about that. So here you can see for now the provisional plan that we have. We are very welcome. We even please ask for feedback. So if you have anything you'd want to see, like just drop us an email when we'll see if we can make that happen. Although schedules tend to be a bit tight, so it's something we'll have to work out. For this year, compared to the previous years, so if some people were there before, we tried to make everything more sort of project-centric, because we'll all be at home, everything will be remote. So we think it's easier to kind of build every lecture around the project. And also, additionally, we think that's a really great thing, because at the end of the day, you will have learned a very practical skill, and you will have actually built something instead of just learned the theory. And with the thing you've built, you'll be able to apply that directly to other projects. So this is why this year we've tried to turn everything more kind of in a practical way. We've also tried to be quite diverse, even though we can't have 40 lectures, so we've had to kind of squeeze stuff here and there. But we have some kind of forefront machine learning, and also a bit more traditional data science, and also a bit of data engineering. So we've tried to balance that out quite a bit. Now a note on the team. So this is the actual talent development team. We also have some teaching assistants that will help us during the actual lectures. So again, feel free to contact any one of us, and it will be a pleasure to help. Now, very importantly, we dearly encourage you to join our society now. We have 2 links. If those can be published in the chat, that'd be great. Yeah, I see they were published. Cool. So we have a link for Imperial students and a link for non-Imperial students, and in either case, you'll be added to the mailing list, and you'll receive all of the necessary information for that. Cool. So now, if you have any additional questions, this is the time. So just drop them in the Q&A session, and you can now hop on the. If you want to go to the next slide, there will be a link. You can now hop into the quiz to maybe win a £10 Amazon voucher. Cool, is that working? Yeah. And in any case, we thank you for attending, and we hope we'll be able to bring you as many events as we can this year, and really thrust your knowledge for data science, despite of the consequences we're facing this year. We'll just, in the meantime, we'll just hang around to see if there are any questions, and otherwise, have a great day, and we hope to see you in our lectures.